NASA has recently raised alarms about the increasing chances of a massive asteroid striking Earth in 2032, sparking global concerns. As humanity continues to gaze into the boundless expanse of space, it becomes evident that Earth is surrounded by growing threats, ranging from massive asteroids like Bennu to rogue planets and even ominous black holes. These cosmic intruders have triggered NASA and other space agencies to be on high alert, with experts racing to understand whether these space objects could potentially cause global catastrophes. The question on everyone's mind is, are we truly safe? The answer may be far more shocking than you imagine. Dare to uncover the cosmic dangers that lie beyond our planet, as we explore the terrifying possibilities they may bring. Bennu, a towering asteroid eyeing Earth. Bennu, an asteroid roughly the size of a skyscraper, has captured the fascination of scientists worldwide. Discovered in 1999 during a large-scale search for space rocks near Earth, Bennu was initially designated 1999 RQ3X. As astronomers observed Bennu, they quickly realized that its orbit could bring it dangerously close to Earth, making it a target for serious study. Despite its small size, Bennu's trajectory occasionally brings it near our planet, prompting NASA to carefully monitor its path over the years. By employing radar technology and other tools, scientists have been able to chart Bennu's orbit, study its shape, and even measure its mass. A particularly important factor in tracking Bennu is the Yarkovsky effect, a force that subtly alters its orbit as a result of its rotation and how it absorbs heat. Even the slightest of shifts can accumulate over time, making it challenging for scientists to predict Bennu's exact position in centuries to come. In 2016, NASA launched the OSIRIS-REx mission to study Bennu in greater detail. After a 2-year journey, the spacecraft reached its destination, mapped Bennu's surface, and even gathered a sample from it in 2020. In September 2023, this sample was returned to Earth, where researchers are analyzing the dust and rocks to uncover clues about the early solar system. Bennu's ancient material could shed light on how planets were formed, and perhaps even offer hints about the origins of life. As of now, the chances of Bennu colliding with Earth remain very low, less than 1%. However, as more data is collected and technology improves, scientists will continue to refine their predictions, ensuring that we're always prepared for what the future might hold. Tracking Bennu not only helps in defending our planet from potential impacts, but also opens doors to understanding the universe we call home. Each trip around the Sun brings Bennu slightly closer or farther from Earth, affected by both natural forces and the Yarkovsky effect. The OSIRIS-REx mission has been a major leap in our ability to understand and monitor this asteroid, and its findings may one day help us protect Earth if needed. APUS, the cosmic roller coaster that keeps us guessing. APUS is another asteroid that has captured the attention of scientists. Discovered in 2004 by Roy Tucker, David Tholen, and Fabrizio Bernardi at the Kitt Peak National Observatory, APUS came close to Earth just a few months later, passing within 9 million miles. Though that may seem distant, in the vastness of space, it's considered relatively close, prompting scientists to study its orbit with great interest. In the years that followed, early predictions suggested that APUS might pose a threat to Earth in 2036, sparking concerns among the scientific community. However, in 2013, better measurements from the Goldstone radar facility showed that the likelihood of a collision in 2036 was less than 1 in a million, providing much-needed relief. Additional observations in early 2013 further reduced the risk, bringing the chances down to around 7 in a billion, effectively erasing the immediate danger. Researchers also examined APUS's orbit to see if it could pass through a keyhole in space, a region where Earth's gravity might change its path and bring it closer to our planet in the future. By 2021, thanks to data from NASA's Jet Propulsion Laboratory, JPL, scientists were able to track APUS's trajectory with incredible accuracy, reducing the margin of error to mere miles. With this newfound precision, experts are confident that APUS will not pose any serious risk to Earth for at least the next 100 years. Though APUS no longer poses a significant threat, it remains under close surveillance, reminding us that our cosmic neighborhood is filled with drifting space rocks. As we continue to monitor these objects, NASA ensures that we stay vigilant and ready for anything space might throw our way. Solar flares, a fury from the Sun. While space harbors many dangers, the Sun itself is a potent force. Solar flares, intense bursts of energy, serve as a reminder of the unpredictable nature of our nearest star. These PBI, these powerful flares send radiation and charged particles toward Earth, disturbing our magnetic field and creating geomagnetic storms that can have wide-reaching consequences. One of the first signs of a solar flare is the disruption it causes to communication systems. Radio signals, including those used for GPS and air traffic control, can become weak or even disappear entirely. Satellites, which are essential for global communication, weather forecasting, and navigation, are also at risk of being damaged by the powerful bursts of energy from solar flares. A massive solar flare could potentially overload power grids on Earth, sending surges of electricity through transformers and other vital equipment, leading to blackouts that could last hours or even days. The infamous Carrington event of 1859 is a prime example of what can happen when a solar storm strikes. Telegraph wires across the globe caught fire, causing sparks and even damaging equipment. However, solar flares aren't all doom and gloom. They can also create breathtaking auroras, those glowing bands of light that appear in the polar regions when charged particles enter Earth's atmosphere. During a solar storm, these auroras can extend far beyond their usual range, offering a spectacular light show in the night sky. Scientists around the world are constantly monitoring the sun's activity, using telescopes and specialized instruments to track solar flares in real time. With improved forecasting, we can protect vital infrastructure and satellites, ensuring that solar flares' beauty doesn't come at the cost of our technology. Rogue planets, nomadic worlds on the move. Beyond our familiar planets, there's another class of mysterious celestial objects, rogue planets. These wandering worlds drift through space untethered by any star. Rogue planets can form in one of two ways, either from the collapse of a gas cloud, similar to the formation of stars, or they may be ejected from a young solar system after a violent gravitational interaction. Scientists don't know exactly how many rogue planets exist, but estimates suggest that our galaxy could host billions or even trillions of these wandering objects. Because rogue planets don't shine like stars, they're incredibly difficult to detect. But with the help of advanced telescopes, such as the upcoming Nancy Grace Roman Space Telescope, we may be able to learn much more about these elusive worlds. While the chances of a rogue planet colliding with Earth are exceedingly slim, the potential consequences of such an event would be catastrophic. A rogue planet crashing into Earth would unleash an unimaginable chain of events, triggering massive earthquakes, tsunamis, and volcanic eruptions. The debris in the atmosphere would block out the sun, plunging the planet into a prolonged cold spell. Despite the highly unlikely odds of a rogue planet causing harm, these objects serve as a reminder of how much we have yet to understand about the cosmos. Rogue stars, intergalactic wanderers. Rogue stars, like rogue planets, are celestial objects that have been ejected from their home galaxies and now drift freely through space. First observed in 1997 in the Virgo galaxy cluster, rogue stars present an exciting yet alarming aspect of the universe. Various theories explain how rogue stars are formed, including the idea that galaxy collisions can throw stars into intergalactic space, or that supermassive black holes at a galaxy's center can fling stars away when they get too close.